Hi guys, and welcome to another video. And as you can see, this is part 2 of grade 11 and 12 Maths Analytical Geometry complete exam question, everything you need to know from the November 2018 examination paper. Now, this is question 3 and it reads as follows. In the diagram, K is minus 1 and 2, L and vertices of triangle. Now we looked at part 1 and we explained the first few questions, which is finding the gradient, the size of theta, the angle of inclination, gradient. We looked at the other formula as well. So we looked at y2 minus y1 over x2 minus x1, and also m is equal to tan of theta. So these are the questions that we've already solved. So this is the part 2 video. So let's get straight into it. If you haven't watched part 1, then watch part 1 before you watch this part, which is part 2. So let's go straight into it. It says it is further given that Kn equals to Lm. Calculate the possible coordinates of L. Now, they are telling us that Kn equals to Lm. And as you can see, we've just found the length of Kn, which is, well, I wrote it here, which is the square root of 13 or root 13 units. There's Kn here, Kn. Now they're telling us that Kn is equal to Lm. Calculate the possible coordinates of L. So let's go and have a look at that. So if we construct a line from L all the way to M, we know that this is going to equal to square root of 13 units. So basically, if we let the coordinates of L equal to x and y, what can we see? Well, we can now use the distance formula and we can get an equation in terms of x and y. What else do we know? Well, if we go look at some of the questions that we've calculated already, it says in question 3.3, it says determine the equation of the straight line KL in form y equals to mx plus c. And 3.3, we've got the answer is y equals to x plus 3. So if you look at that, y equals to x plus 3. So we've got the equation of this line, which is y equals to x plus 3. Therefore, we'll have simultaneous equations. We've got two equations in terms of x and y because both go through point L. So let's go and set that up, and we have a simultaneous equation question here. So therefore, for 5 marks, I'm sure we can solve this question. So 3.5.1. Firstly, let's set up the equation for Lm. So Lm will equals to, so we got Lm equals to our distance formula x2 minus x1 all squared plus y2 minus y1 all squared equals to. So we'll say Lm equals to either the square root of this whole thing, or we can say Lm squared. So we'll say root 13 all squared equals to x2 minus x1 all squared will give us x minus 3. X minus 3 is x plus 3. Let's go and write that down. X plus 3 all squared plus, what do we have here? Y minus 5, let's say y plus 5, right? So y plus 5. I'm doing that because I often do that. Minus is a plus. Minus times a minus is a plus. So square root of 13 all squared is 13 equals 2. So let's square this binomial, and that's quite important for us to know in mathematics. How to square a binomial. Square the first term, x squared. Double the product of the two terms. X times plus 3x. X times plus 3 is plus 3x. Double it is plus 6x. And square the last term is plus 9. Remember, when you square something, the result is positive. So plus 3 all squared is plus 9. And here we're going to have plus. So the sign would not affect anything in brackets. So therefore we don't have to include the brackets after that. So we can just say plus y squared. Y times plus 5 is plus 5y times 2 is plus 10y. That's called doubling the product of the two terms. And square the last term is plus 25. So if if we now look at that, we have the following, which is 13 equals to x squared plus y squared 6x, and we've got 25. So now what we're going to do, so let's substitute. We've also got y equals to x plus 3, right? So we can call that equation 1, and we've now got equation 2, which is y equals to x plus 3, and this one is from 3.3. So we can just write here from 3.3. Okay, so wherever we got y, what we're going to do is we're going to put x plus 3. So we've got x squared plus 6x plus 9, and y squared now will be plus x plus 3 squared plus, and here we got 10y, so we're going to put 10 into x plus 3 plus 25, right? If we wanted to, we could have substituted it up here, okay, and then open up the brackets. Doesn't make a huge difference. So 13 equals to, we'll say x squared plus 6x plus 9. And here we're going to square this binomial again, so it's going to be plus x squared plus 6x plus 9. Open this brackets out, so that'll be plus 10x plus 30 plus 25. So therefore, we're going to get a quadratic equation in terms of one variable, which is x. So let's make one side equals to 0. So let's simplify. X squared plus x squared is 2x squared. And let's see what we have here. Plus 6x, and plus 6x is plus 12x. And 12x plus 10x is plus 22x. It's plus 22x. And here what do we have? We've got 9. Plus 9 is 18. 18 plus 30 is 48. And 48 plus 25. 48 plus 25 will give us, that'll be 8 and 5 is 13, 6 and 73. And remember, now we're going to take this 13 over to the other side, so it'll be 73 minus 13, which should leave us with 3 minus 3 is 0 there, 7 minus 1 is 6. So we're left with positive 60. We've got plus 60. Now at this particular point, we need to factorize this quadratic equation. Right, so let's look at that. So if you divide across by 2, so that'll be 0. So I'll get x squared plus 11x, and that'll be plus 30. Right, so 0 equals 2. So let's see if we can factorize this very quickly. Factors of 30 when multiplied together to give me 30. Add it together to give me positive 11. So that'll be 30 plus 30. So I'm going to use plus 5 and plus 6. Plus 5 and plus 6 is plus 11. And if I multiply plus 5 to plus 6, I'll get plus 30. So therefore, my factors will be as follows. X plus 5 and x plus 6. X plus 5 and x plus 6. Now I know that some of you use the calculator to factorize quadratic equations. You may do so in an exam setting, but remember, it's important for you to be able to also do this by inspection. So therefore, x is going to equals to minus 5, or x equals to minus 6. So what do we know? We're going to now substitute in y equals to x plus 3, which is our equation 2, to find the y values. X plus 3. So therefore, our y values will be as follows. So that'll be minus 5 plus 3 is minus 2. Or y equals to, so we're going to get minus 6 plus 3 is minus 3. So the possible coordinates of L will be minus 5 and minus 2. Or minus 6, minus 3. So we got minus 5 and minus 2. We got minus 6 and minus 3. Alright? So that's our answer for 3.5.1. Let's look at 3.5.2. In 3.5.2 it says determine the coordinates of L. If it is given that KLMN is a parallelogram. So let's go look at KLMN. So KLMN. So let's join KLMN. So we're just joining M and N now. First of all, what are the properties of a parallelogram? Opposite sides equal. So opposite sides equal and parallel. What else? Opposite angles are equal. This one. Third one will be that the diagonals bisect each other. So let's write that down. Diagonals bisect each other. Right, so these are the three main properties of a parallelogram. So we need to use one of these properties to solve this question. They're telling us once again, determine the coordinates of L. It is given that KLMN is a parallelogram. So there's the coordinates of L here. Okay. Now we already found the possible coordinates of L, but now we want to find the specific coordinates of L, because now we're given that this figure is a parallelogram. So you must know your properties of quadrilaterals. So let's look at this diagonal L, and if we draw a diagonal here which is KM, you'll notice here that we can now form a midpoint. Okay, and if you look at that, remember that the diagonals bisect each other, which means that the midpoints must be the same. Therefore, we can find the midpoint of K and M. What will the midpoint of K and M be? Well, you can work it out. Minus 1 plus minus 3, which is going to be minus 4 over 2, is going to be minus 2. Minus 1 plus minus 3 is minus 4. Minus 4 divided by 2 is minus 2. Then we can say y1 plus y2 over 2. So it will be 2 added to minus 5 will be minus 3. So it will be minus 3 over 2. So that's the midpoint. So the midpoint of KM must equal to the midpoint of L and N. So now we can use the midpoint formula once again, solve for x and y. So let's have a look at that. Number 1, we're going to now say that the midpoint of K and M is 2 and negative. That is negative 2 and negative 3. Let's go write that down. So for 3.5.2, our solution will look as follows. 3.5.2, we're going to say that the midpoint of Km, so the midpoint of Km is going to equal to, let's write that down quickly, minus 2 and minus 3 over 2. Minus 2 and minus 3 over 2. So it's minus 2 minus 3 over 2. Therefore, we can now say that the midpoint of Km is equal to the midpoint of Ln, midpoint of Ln, because we're given that this is a palm. Remember that the diagonals bisect each other. Therefore, we can now set up an equation to solve for x and to solve for y. So we can now say that x plus 1 over 2 is equal to minus 2. We can say x plus 1 over 2 equals to minus 2. So that will be to solve for x. And so we got x plus 1 over 2 equals to minus 2. And similarly, we can say y plus minus 1 over 2 equals to minus 3 over 2. So there you can look as follows. Y minus 1 over 2 equals to minus 3 over 2. Y minus 1 over 2 equals to minus 3 over 2. And let's solve for x and y. So we have x plus 1 equals to 2 times minus 2 is minus 4. Therefore, x will equals to minus 5. Here we can now cross multiply. 2 times negative 3 is negative 6. Negative 6 over 2 is negative 3. So y minus 1 equals to negative 3. Therefore, y equals to, take the minus 1 to the other side, it's plus 1. Minus 3 plus 1 is minus 2. Therefore, what can we conclude? That the coordinates of L will be, is it here, minus 5 and minus 2, which we've already solved in the previous question. But now we're confirming that coordinate. So it's minus 5 and minus 2. Now let's look at the last question. So the last question is, T is a point on KL produced. Tm is drawn such that Tm is equal to Lm. Calculate the area of triangle KTN. Now when they say that a particular point on KL is produced, it means that first of all, it is going to lie on, this point is going to lie on KL. And produced means it's just going to go a little bit past a particular point. So T is a point on KL produced. So what they're saying is that it's going to look something like this. So first of all, let's just make up some space here. Alright, so that should do. Now, it's a point on KL produced, which means that it's going to be somewhere here. Right, so it's going to be produced on KL, and what do they call it? They call it point T. So let's relabel it T as well. So T. Now, they're telling us that Lm is equal to Tm. So basically, Lm equals to Tm. So we know that these two are equal. So that's root 13. That's also going to be root 13. What do they want? They want the area of K, T, and M. So there's that area of KTN. Now let's go look at that very carefully. So KTN is going to look as follows. So I'm just going to try and use another color here. So KTN. So I'm just going over it like that. Now what do you notice about this? So KTN is a non-right angle triangle. But we have two sides, which is KN, and we've got KT, but we don't know the length of KT. We've got an included angle. So therefore, we can use the area rule. What's the area rule? So we can now say that the area of triangle KTN is equal to half times, what's this, KT. So that's KT times KN. We already know the side or the length of Kn. We just need to find the length of KT. Let's go look for the previous question if we've solved something with this regard. So let's see. If you look at this question, calculate the possible coordinates of L. If we look here, we've solved this question, and remember that one possible coordinate of L is minus 5 and minus 2. We left with this other point, minus 6 and minus 3. Now, minus 6 and minus 3, therefore, should be this particular point of T. Why is that so? Minus 6 and minus 3. The reason for that is in the question they say that Kn equals to Lm. Now, Kn equals to Lm equals to the square root of 13. So therefore, it was given in the question that Tm is equal to Lm, which means it's equal to root 13. So therefore, the coordinates of T has to be minus 6 and minus 3. So now that we know the coordinates of T, we can find the distance of KT. And once we find the distance of KT, we know the distance of Kn, and just to complete this particular formula. Half times kt times kn times sine of the included angle, which will be tkn. So that will be tkn. So let's go and write our solution down. So therefore, for 3.6, we're going to write the following. So we're going to say that number 1, we're going to say kt. So we've got kt is going to equal to our distance formula is as follows. Square root of x2 minus x1 all squared plus y2 minus y1 all squared, which is equal to, let's look at that. So that'll be minus 1 minus 6, so minus 1 plus 6. So that'll be minus 1 plus 6 all squared minus 1 plus 6 all squared plus y2 minus y1. Let's go look at that quickly. So that'll be 2 minus 3, which will be 2 plus 3 all squared. 2 plus 3 all squared equals 2. Let's just put that in our calculator. So we got the square root of minus 1 plus 6 all squared plus 2 plus 3 squared. Let's write that properly. Okay, brackets. So there we go. So 5 root 2 therefore we know that now kt is equal to 5 root 2. And what else do we need? Kn is equal to root 13. Kn is equal to the square root of 13. And where did we calculate that? Kn. That is from 3.4. You can just write here. From question 3.4. Therefore, we can conclude that the area of triangle KTN is equal to half times KT times KN times sine. We're using the area rule for a non-right angle triangle. Sine of TKN, which is going to be 78.69 degrees. Sine of TKN, so that will equals to half times 5 root 2 times root 13 times sine of 78.69. 78.69 degrees. Let's put that in our calculator. Half times 5 root 2 times root 13 times sine of 78.69. And that's 12.499. If you round off to 2 decimal places, we get 12.5 units squared. And that's our solution, learners, for the area of triangle KTN. If you haven't subscribed already, make sure to subscribe to JR Maths, share this content with your friends, and also like my Facebook page, Justin Lazarus Mathematics. You can watch all videos in all of the work schedule on jrmaths.com. And I'll catch you in the next video.